In January of 2026, three physicists published a paper in the journal Entropy that most people will never hear about. Its conclusion was quiet and catastrophic. The pattern of neural activity currently happening in your brain, the pattern that constitutes your memories, your perceptions, your entire sense of who you are and where you came from, is statistically far more likely to be a random fluctuation that popped into existence a few seconds ago than to be the genuine record of an actual life. Your childhood may not have happened. The people you remember loving may never have existed. And the universe, as far as we can tell from the best physics we have, is not equipped to tell you which version is real. Tonight we are going to follow this question as far as it goes, through a 2025 neuroscience study that proved your brain can fabricate a seamless, convincing reality from nothing at all, through the corridors of quantum mechanics, where observation itself seems to pull a definite world into being, through the philosophical zombie that looks exactly like you and has no one home inside, through the machines that have begun this year to claim they are conscious, and finally, into the strange and beautiful place where the most terrifying question a mind can ask stops being terrifying and becomes something else entirely. What if you are the only real person? What if everyone you love is a convincing surface with no inner life behind it? These are not fringe questions. They sit at the center of modern physics and neuroscience, and the answers, such as they are not what you have been told. So settle in, turn the lights down, let the world outside quiet. Tonight, you are going to meet the oldest and strangest question a consciousness can ask itself, and you are going to meet it honestly, all the way through, until the morning comes. If you enjoy our calm nighttime journeys, remember to like and subscribe. We highly encourage our community to discuss the video topics in the comments and react to other comments. It's the most fun when we share our thoughts. Now, let's begin. Tonight we are going somewhere most documentaries will not take you. Not outward, into the stars. Not downward, into the ocean. Tonight we are going inward, into the soft, dark chamber behind your eyes. Into the single most uncomfortable question a conscious mind can ask: what if you are the only real person? What if every face you have ever loved, every voice that ever made you feel seen, every stranger who ever smiled at you, has no inner life at all? What if you have been alone in a way you cannot even imagine for your entire life? Over the next 2 hours, we are going to follow this question wherever it leads. Through a study released in April of 2025, which proved your brain can fabricate a perfectly convincing reality from absolutely nothing. Through a paper published in January of 2026, which argued that your entire life, your childhood, your memories, every person you remember loving, are statistically more likely to be a random fluctuation than a real history. Through the corridors of quantum physics, where observation itself seems to pull reality into being. Through the laboratories where machines now claim to have inner experience. And finally, into the gentle, unexpected place where this question stops being terrifying and becomes something else entirely. So settle in, close the curtains, let the world outside quiet down. Chapter 1. The night your brain faked an entire universe. Let us begin with something you already know, but have never quite let yourself sit with. Last night, while your body lay still in the dark, while your eyes were closed and your muscles were paralyzed and no sound penetrated your room, your brain did something extraordinary. It built an entire world, rooms you had never entered, streets that do not exist, faces of people you have never met in waking life. Conversations so vivid that your heart rate changed, your breathing shifted, real fear, real longing, real grief, or real joy washed through your body. All of it triggered by events that were happening nowhere except inside a single organ sealed inside your skull. And here is the part that should unsettle you. While you were inside that fabrication, You believed it completely. Not once, in the middle of your dream, did you pause and say, "This cannot be real." The dreamer and the audience were the same organ. You already possess, every single night of your life, direct, uncontestable proof that your brain is capable of generating a seamless, convincing reality without a single piece of information coming from outside. And now the question lands. The organ that did that last night, that built an entire false world and sold it to you as truth, is the same organ telling you right now that what you are experiencing in this moment is fundamentally different. The same organ, the same processes, the same wet electrochemical machinery. How do you know? How do you actually know? Take a breath, sit with that, because it is going to get stranger. Here is a fact so obvious, it is almost invisible. You have never, in your entire life, experienced anything outside your own body. Not once. Every sunset you have ever watched, every song you have ever loved, every face you have ever kissed, all of it arrived as electrical impulses. Tiny voltages traveling along nerve fibers at about 100 meters per second, flowing into a sealed, silent, lightless chamber of bone. Your brain sits in absolute darkness. It floats in cerebrospinal fluid. It has no windows. It has no microphones. It has never once directly seen a sunset or heard a voice. It has only ever received coded electrical signals, and from those signals, it has built everything you have ever called reality. Consider the color red, the redness of a rose. You probably feel certain that the redness exists out there, in the petals, in the world. It does not. The rose reflects electromagnetic radiation with a wavelength around 700 nanometers. That wavelength carries no color. It carries no warmth, no beauty, no meaning. It is simply a frequency. The redness is a tag your visual cortex invents. It is a label your brain assigns to that frequency, because somewhere in your evolutionary past, distinguishing red from green helped your ancestors survive. The color you see is not in the rose. It is in you. The same goes for warmth. The sun does not feel warm. It emits infrared radiation. That radiation carries no feeling. Your skin has thermoreceptors that convert the radiation into nerve signals, and your somatosensory cortex decides, based on the signal pattern, to render a feeling called warmth. The warmth is inside you. The sound of a violin is inside you. The smell of rain is inside you. Every single thing you have ever experienced has been, in the most literal neurological sense, an inside job. Your entire life has been spent in a sealed chamber, watching a show your own brain is producing, based on coded signals that it cannot verify. Now, for a long time, you could still comfort yourself with the thought that your dreams feel different from waking life. Dreams are blurry, the comfort went. Dreams have gaps. Dreams you eventually recognize. Reality is sharp and consistent and checkable. In April of 2025, that comfort was taken away. Researchers at Radboud University Medical Center in the Netherlands published the largest electroencephalography study of lucid dreaming ever conducted. Lucid dreaming is the state in which a sleeper becomes aware, inside the dream, that they are dreaming. What the researchers found was extraordinary. The brain during lucid dreaming produces a distinct signature: reduced beta band power, heightened gamma activity, patterns that do not match ordinary waking consciousness, and yet also do not match ordinary REM sleep. It is a third state, a state in which a person is fully self-aware, fully conscious, fully present, inside a reality that their own brain is constructing from nothing. Read that again slowly in your mind. The brain does not need the outside world to produce the feeling of being an aware person in a real place. That feeling, the solid, undeniable, obvious feeling of being here, right now, is something the brain generates on its own. And when it wants to, it can generate that feeling inside a fabrication just as convincingly as it generates it inside what you call reality. There is no test you can run from inside your own head that distinguishes one from the other with certainty. You can pinch yourself. The pinch will feel real in either case. You can look at your hands. Your hands will look real in either case. You can check the time on a clock. The clock will read whatever your brain has decided clocks should read. Every check you perform is a check that must pass through the same system that is doing the generating. You are asking the hallucinator to verify its own work. And that brings us to the cliffhanger of this chapter, the question that opens the door to everything else. If your brain can produce the sensation of unquestionable reality from nothing at all, if the machinery that fabricated last night's dream is the same machinery presenting this moment to you right now, then what reason do you actually have to trust that this is the real one? The chair beneath you, the person who might be asleep in the next room, the world outside your window. You have no reason other than habit. And the habit, it turns out, has never once been tested. But it gets worse, because mainstream neuroscience, not fringe philosophy, not mysticism, has now concluded something even more disorienting, something that changes the meaning of the word perception forever. And that is where we are going next. Chapter 2. The brain is hallucinating this right now. Most people, without ever stopping to think about it, picture perception as a simple one-way street. The world exists out there. Light bounces off objects. It enters your eyes. The eyes send signals to your brain. The brain reads those signals and shows you what is there. A camera taking a picture. A recording device capturing what is real. This is how almost everyone imagines the process of seeing. It is completely wrong. Neuroscience has known it is completely wrong for about 20 years. And the actual story, once you understand it, will change the way you experience being awake. Here is what your brain is really doing, right now, as you listen to these words. Every 25 milliseconds or so, your visual cortex is generating a prediction, a full rendered guess, a best estimate of what it expects the next moment to look like, and it is sending that prediction downward toward your eyes, toward the incoming sensory stream. The sensory data arriving from your retinas is not, as you have always been told, the main signal. It is a correction, a small error report that says, here is where your prediction was slightly wrong. Here is what needs to be adjusted. Only the difference between the expectation and the reality, what neuroscientists call the prediction error, gets passed back up for detailed processing. This framework is called predictive processing. Its most influential mathematical form has been developed by the neuroscientist Carl Friston at University College London. And it has, over the last 2 decades, quietly become one of the most dominant paradigms in 21st century cognitive science. It has changed how researchers think about vision, hearing, emotion, memory, even mental illness. What predictive processing says, in plain language, is staggering. Most of what you are seeing right now was not delivered by your retinas. It was generated internally. It was assembled from memory, from expectation, from pattern, from habit. Your retinas merely supply a thin stream of corrections to a world that your brain is already painting from the inside. You are not watching reality. You are watching your brain's best guess about reality, very lightly edited by incoming photons. If you have ever wondered why optical illusions work, this is the reason. In an optical illusion, your brain's prediction is so strong that it overrides the sensory correction. The eye sees one thing, the brain paints another, and the painting wins. The neuroscientist Anil Seth at the University of Sussex has given this idea its most unsettling name. He calls it controlled hallucination. In his 2021 book, Being You, and in his ongoing research program, Seth argues that normal waking perception and dreaming are not fundamentally different things. They differ only in how tightly the hallucination is constrained by incoming sensory data. During waking hours, your brain's internally generated reality is corrected moment by moment by what your senses report. The correction keeps the hallucination aligned with the world, more or less. At night, those sensory constraints drop away, and the brain hallucinates freely. But the underlying process is the same. The brain is always generating. The brain is always hallucinating. The difference between waking life and dreaming is a difference of degree, not of kind. In a 2025 interview, Seth went further. He argued that even psychedelic experiences are best understood as the same process, with the sensory corrections loosened rather than disconnected. Quote, "The world does not pour itself into our minds through transparent windows. The brain is always making predictions. Perception is the reader of those predictions, not the author of them." End quote. Sit with what this means. When you look at the person across from you, you are not, in any direct sense, seeing them. You are seeing your brain's best prediction of them. A prediction built from memory, from expectation, from everything your brain has ever learned about human faces. That prediction is being very lightly corrected by the photons bouncing off their skin. The photons are the seasoning. The prediction is the meal, and that is the friendlier version of the story, because there is a harder version, and it comes from the cognitive scientist Donald Hoffman at the University of California, Irvine. In a 2024 paper in the Journal of Consciousness Studies, Hoffman extended what he calls the interface theory of perception. Alongside the mathematician Chetan Prakash, he developed what he calls the fitness beats truth theorem. Using evolutionary game theory, they ran simulation after simulation, pitting two kinds of organisms against each other. In one group, organisms perceived reality as it actually is. In the other group, organisms perceived only what was useful for their survival, no matter how distorted that perception was. Across every simulation they ran, truth went extinct. Creatures that saw reality accurately died out. Creatures that saw useful fiction survived and thrived. The fitness beats truth theorem, Hoffman argues, is not a claim. It is a mathematical result. Natural selection has no interest in accuracy. It has an interest in survival. And survival does not require that you see what is actually there. It requires that you see what keeps you alive. Hoffman's conclusion is blunt. Evolution did not design your perceptual system to show you the world. It designed it to show you a desktop, a set of fitness-relevant icons. The red apple you see is no more similar to the underlying reality than the little blue folder icon on your computer screen is similar to the voltage patterns running through your hard drive. The folder icon is not the folder. It is an interface, a simplified cartoon that lets you interact with something you could never perceive directly. In his 2024 paper, Hoffman pushed the argument even further. He proposed that space and time themselves may be part of the interface, not features of the underlying reality, just icons, convenient illusions that allow a finite brain to interact with something vastly stranger than space and time. Now, place these three pieces together. Your brain generates perception from the inside and merely corrects it with sensory data. This process is neuroscientifically indistinguishable from dreaming, only more constrained. And the whole system was never designed to show you what is real. It was designed to show you what is useful. You are not seeing the world. You are seeing an interface your brain has built, tuned by millions of years of evolution, corrected only lightly by a thin stream of signals it cannot verify. Which leads to the question that drags us out of neuroscience and back into the oldest problem in philosophy. If perception was never built for truth, if your brain is running an evolutionarily tuned hallucination that has no guaranteed relationship to what is actually out there, then the question is no longer whether your reality is a construction. That question has been answered. Your reality is a construction. The question now is, whose construction is it? Is it a shared construction, built in parallel by many minds, negotiated and cross-checked until something like a consensus reality emerges? Or is it yours alone, a private theater with a single audience, performing for no one but you? And if you cannot see behind the interface, you cannot answer. Nobody can. Because every test you might perform to verify the existence of other minds is a test that must be performed inside your own interface, inside your own controlled hallucination, inside the sealed chamber where your brain has been generating reality for every second of your life. At this point, a thoughtful viewer might push back. All right, you might think, my perceptions are constructed, but surely my memories are solid. I remember my childhood. I remember yesterday. I remember the people I have loved. Those memories are real. They are records. They are history. Whatever else might be uncertain, at least I have the past. In January of 2026, 3 physicists published a paper that took that last comfort away. Chapter 3. Your memories are statistically fake. In 1896, a brilliant and tormented Austrian physicist named Ludwig Boltzmann was wrestling with one of the strangest puzzles in all of physics. Why is the universe so improbably ordered? Why do we see stars in clusters, galaxies in structure, planets with stable orbits, life with staggering complexity? The second law of thermodynamics says that entropy, a measure of disorder, should be increasing everywhere. Systems should be falling apart, not building up. And yet, everywhere we look, we see order. How? Boltzmann proposed an answer. If the universe is large enough and old enough, and random fluctuations in matter and energy are possible, then over infinite time, rare pockets of order will occasionally emerge by sheer chance. The universe we see, he speculated, might simply be one of those pockets, a statistical fluke in an otherwise dead, disordered cosmos. This idea seemed clever at the time. It explained a paradox. But Boltzmann never saw the horrifying consequence hiding inside his own solution. It would take other physicists, decades later, to notice it. And when they did, the word they gave it captured the nightmare perfectly. The Boltzmann brain. Here is the logic. In a universe that allows random fluctuations over infinite time, the probability of any given configuration of matter arising by pure chance is not zero. It may be unimaginably small. But across infinity, unimaginably small means it happens eventually, and then happens again, and again, without end. Now, consider 2 possibilities. Possibility 1. A random fluctuation produces an entire observable universe, billions of galaxies, a planet Earth, a biosphere, a species that evolves into you, sitting here, listening to this, having the exact thoughts and memories you are having right now. The probability of this is almost infinitesimally small because it requires fluctuating the correct state of an entire universe. Possibility 2. A random fluctuation produces just a single brain. A brain with your exact memories, your exact beliefs, your exact sense of being a person sitting in a chair, listening to a documentary. Nothing else. No body, no chair, no room, just a brain floating in the dark, lasting perhaps a few seconds, before dissolving back into the chaos it came from. The probability of this is also vanishingly small, but it is vastly, vastly higher than the probability of fluctuating an entire universe, because you need far less matter, far less organization, far less coincidence, and that is the horror. In any cosmological model that allows infinite random fluctuations over infinite time, Boltzmann brains statistically outnumber real observers by margins that cannot be written down without exhausting most of the notation mathematics has invented. Not 1,000,000 to 1, not 1,000,000,000,000 to 1, ratios with hundreds of zeros, thousands of zeros, numbers so large they make the actual count of atoms in the visible universe look like a rounding error, which means, on pure probability, if you are an observer in such a universe, You are far more likely to be one of them than to be what you feel you are, a real person with a real history in a real world. For decades, most working physicists shrugged this off. They called it a reductio, a sign that any cosmological model predicting dominant Boltzmann brain observers must be wrong for that reason. Sean Carroll, the prominent theoretical physicist at Johns Hopkins, has argued exactly this. If your theory says most observers are random brain fluctuations, your theory has failed a sanity test and should be discarded. That was the comfortable consensus. And then, in January of 2026, 3 physicists punched a hole in it. David Wolpert of the Santa Fe Institute, Carlo Rovelli, one of the world's most celebrated theoretical physicists, and Jordan Scharnhorst. Together, they published a paper in the journal Entropy titled Disentangling Boltzmann Brains, the Time Asymmetry of Memory, and the Second Law. Published January 9th, 2026. Volume 27, Issue 12, Article 1227. Their argument is technical, the mathematics is careful, but the implication, stated plainly, is devastating. The time-symmetric structure of Boltzmann's own H-theorem, the very equation Boltzmann wrote to explain the second law of thermodynamics, implies something that most people, even most physicists, have never fully confronted. Formally, it is far more probable for the specific pattern of neural activity currently present in your brain, the pattern that constitutes your perceptions, your memories, your sense of a past, to have arisen from a random fluctuation in the recent past, than to be the faithful record of an actual history. The authors do not claim you are a Boltzmann brain. They are too careful for that. What they claim is that the paradox cannot be dismissed as casually as physicists have been dismissing it, that it touches something real and unresolved about the relationship between entropy, memory, and the direction of time, that the argument for your own cosmic normality is much weaker than we have been pretending. Translation. In 2026, the case that your entire life history is statistically more likely to be a spontaneous fluctuation than a genuine sequence of events is stronger than it has ever been. It is not a fringe idea. It is sitting inside a respectable physics journal authored by some of the most serious thinkers in the field. Now, here is the terrifying elegance of the whole scenario. You cannot check. No experiment can distinguish between you and a fluctuation. Every piece of evidence you might cite to prove your history is real, every photograph, every old letter, every scar on your body, every person who remembers you from 10 years ago, every scientific measurement confirming the age of the Earth and the age of the universe, every single piece of evidence is itself part of the pattern that a random fluctuation would produce. A fluctuation brain has fluctuation photographs. A fluctuation brain has fluctuation. Friends who fluctuation remember it. The universe around you and the fake universe around a Boltzmann brain are, by definition, experientially identical. You cannot step outside yourself to check. There is no outside from which to look in. So what are we left with? Let us just count the walls that have closed in over the last 3 chapters. Wall 1. Your brain generates a convincing reality without needing external input. Dreams prove it. Lucid dreaming proves it sharper. You have no way to verify, from inside, whether this moment is the fabricated kind or the corrected kind. Wall 2. Even when you are awake, what you call perception is a controlled hallucination, a predictive model generated by your own brain, an interface, your evolution, built for survival, not for truth. Wall 3. Your memories, your past, your history, the archive of everything you think you have been. Statistically, more likely, in any universe allowing infinite fluctuation, to be a few seconds old than to be decades old. What, exactly, can you still trust? The only thing that remains, the only fact no argument can erase, is this: something is experiencing this moment, even if everything else is hallucination, even if every memory is a fake, even if no world and no other mind exists. Something is here, experiencing the fact of being here. That much cannot be doubted. The doubt itself is an experience, and an experience requires an experiencer. 4 centuries ago, a French philosopher, sitting in a small room beside a warm stove in Germany, arrived at exactly this realization. He thought it would be the foundation on which he could rebuild everything he had doubted away. He thought it would lead him back to the world. It did not. It led him somewhere much darker, and nobody, in the 400 years since, has been able to find the way out. Chapter 4. The Man Who Tried to Doubt His Way Out. The year is 1641. The place is a small heated room in a house in the German countryside during one of the coldest winters Europe had seen in decades. A French philosopher and mathematician named René Descartes has pulled a chair close to the stove. He has a writing desk, a notebook, and a plan. The plan is audacious. He is going to doubt everything. Not as a crisis, not as a breakdown, as an experiment, a deliberate, systematic, philosophical experiment to find out whether there is anything at all that a thinking mind can know with absolute certainty. He calls it, in his own writing, the method of doubt. And the rule is simple. If he can imagine even a faint, far-fetched reason to doubt something, he will set it aside. Not necessarily reject it forever, but refuse to rely on it as a foundation. He will keep stripping away, belief after belief, until only what cannot be doubted remains. He begins with the senses. Can he trust his eyes and ears and skin? No. He has been deceived before. The stick looks bent in water and is not. Distant towers look round and turn out to be square. His senses have lied to him many times, and a faculty that has lied before cannot be the bedrock of certainty. He moves to the physical world. Surely his body exists. Surely this room, this stove, this winter night are real. But then he stops. He has had dreams so vivid that while he was inside them, he believed them fully. He has woken up from dreams certain that he was sitting at a writing desk beside a stove in a German room. How does he know, right now, that he is not dreaming? Every test he could run from inside a dream would feel the same. He sets the physical world aside, not because it is not real, but because he cannot prove it is. He moves to mathematics. Surely 2 + 3 = 5. Surely a square has 4 sides. These truths seem to shine with their own obvious light. But then he imagines the hardest possibility of all. What if, he writes, some powerful deceiver, some malevolent intelligence of enormous cunning, has arranged things so that even the simplest logic is a trap? What if every time he counts, the deceiver plants a false certainty in his mind? He cannot rule this out, so he sets mathematics aside too. Layer after layer, he strips the world. His senses, gone. His body, gone. The physical world, gone. Even mathematics, gone. He is reduced to almost nothing. He sits in the dark with nothing he can be sure of. And then he notices something. Something that the doubt itself has made visible. The doubting is happening. Something is doing the doubting. Whatever this thing is, whatever strange sealed interior is running the experiment, it exists. Because if it did not exist, there would be nothing to deceive. There would be nothing to doubt. The act of doubting proves that a doubter is present. He writes the sentence that would echo for 400 years. Cogito, ergo sum. I think, therefore I am. You need to feel the weight of what this really means. At the bottom of the most rigorous skepticism ever performed, only one thing survives certain. Not the world, not the body, not the stars, not mathematics, not other people, only the fact that some mind is present, experiencing the doubting, your own mind, whatever else is in question, your own existence as a conscious experiencer is not. This is the secure foundation Descartes was looking for. And this, exactly this, is the moment solipsism was born, in its formal, modern form. Because every layer beyond that single certainty has to be rebuilt, if it can be rebuilt at all, on that single foundation. What is rarely taught in introductory philosophy classes is what happens next. Descartes, having pared his world down to the cogito, tries to build it back. He wants his body back. He wants his room back. He wants other people back. He wants the physical world back. And the argument he uses, after all that rigor, is surprisingly weak. He argues that his mind contains an idea of a perfect being, a perfect God. Since an imperfect mind could not on its own generate the idea of perfection, the idea must have been placed there by a perfect being who actually exists. And since a perfect being, by definition, would not be a deceiver, the physical world must be real. The senses, while sometimes misleading, cannot be systematically false. The external world comes back. Philosophers have been pointing out, for nearly 4 centuries, that this argument cheats. It smuggles in assumptions his own method of doubt should have excluded. You cannot use an idea, however pure, to prove the existence of something outside your own mind, when your own mind is the only thing whose existence you have successfully demonstrated. The door Descartes opened, he opened with a key he did not actually possess. Once you seriously doubt the external world, no amount of clever argument about perfection gets it back. Not honestly. A century later, the Irish philosopher George Berkeley followed the logic much more consistently. His argument was simple. If all we ever directly experience are perceptions, ideas in the mind, then what reason do we have to believe in a material world behind those perceptions? None. The material world is an unnecessary extra step, a theoretical appendage that explains nothing we do not already have. Berkeley concluded that matter, as an independent substance outside the mind, does not exist. Objects only persist when nobody is perceiving them because God, always perceiving everything, keeps them in existence. Strip away Berkeley's theology, remove the divine observer, and what you are left with is pure, naked solipsism. A world consisting of perceptions, with nothing behind them, arising in a single consciousness that has no guarantee any other consciousness exists. The philosopher John Horgan, who has written extensively on the limits of science, once described solipsism as, quote, at once utterly illogical and irrefutable, end quote. And that strange pairing is the secret of its persistence. Nobody walks around believing they are the only mind in the universe. It feels absurd. Your whole life screams against it. And yet, in 24 centuries of philosophy, no one has produced a conclusive argument that rules it out. Even Ludwig Wittgenstein, the great 20th century philosopher, took a swing at it with what is now called the private language argument. He argued that meaning itself is a social phenomenon, impossible in principle for a single isolated mind. His followers have declared solipsism defeated. His critics have pointed out that the argument assumes exactly what it is supposed to prove. The debate continues. The Stanford Encyclopedia of Philosophy entry on the problem of other minds, last revised in December of 2023, acknowledges openly that the core problem remains unsolved. Every generation of thinkers has tried to kill solipsism. Every generation has failed. And now, in our own century, the challenge has come from an unexpected direction. Not from philosophers, from physicists, from the laboratories where the most fundamental behavior of matter is studied with the most precise instruments humans have ever built. Physics, the science that was supposed to give us an objective world independent of the observer, has begun to do something very strange. It has begun to suggest that the observer cannot be removed from the picture. The laboratories have discovered something the philosophers never suspected. Observation, it turns out, does something that no equation can describe. And once you see what it does, the sealed room of your own mind begins to echo. Chapter 5. When observation reached into the lab. The story of how physics fell into the trap of the observer begins with an experiment so simple that a bored high school student could sketch it on a napkin. A barrier with two narrow slits, a screen behind the barrier, a source that fires particles, one at a time, toward the barrier. That is it. That is the whole setup. Send classical particles through such a system, like tiny marbles, and you get exactly what you would expect. Two stripes on the screen, one behind each slit. Each particle went through one or the other. Simple. Send waves, like water ripples, through the same system, and you get something else. The waves go through both slits at once, and the crests and troughs interfere with each other on the far side. On the screen, you see an interference pattern, a series of alternating bright and dark bands. Also simple. Now send electrons, or photons, or any other quantum particle through the experiment, one at a time, slowly, carefully. You might expect them to behave like tiny marbles. They are particles after all. They should go through one slit or the other and leave two stripes on the screen. They do not. They leave an interference pattern. Each individual particle, arriving one at a time, somehow produces the signature of a wave. Which means each particle, in some sense, passed through both slits at once and interfered with itself on the way to the screen. Strange enough. But now comes the detail that broke physics. Place a detector at the slits, a device that simply records which slit each particle went through, just one little sensor that gathers information about the path. The interference pattern vanishes. The particles now behave like particles. Two stripes, no wave behavior. The moment you obtain information about which path the particle took, the particle stops behaving as if it took both paths. Turn the detector off, and the interference returns. Turn it back on, and it disappears again. The act of gathering information about the path physically changes what the particle does. Richard Feynman, one of the greatest physicists of the 20th century, once said of this experiment, quote, "A phenomenon which is impossible, absolutely impossible, to explain in any classical way, and which has in it the heart of quantum mechanics," end quote. Now here is where we have to be very careful, because this is where popular explanations go off the rails. It is not, strictly speaking, human consciousness that causes the change. It is not that the particle somehow knows you are watching and decides to behave differently out of shyness. The change is caused by the physical interaction required to detect the particle. To know which slit it went through, something has to physically interact with the particle. A photon, a field, something. And that physical interaction is what collapses the wave behavior. Good. That seems to let us off the hook. Consciousness is not doing anything magical. It is just physics. And yet, the deeper problem does not dissolve. Because the question becomes, what exactly counts as a measurement? Where does physics draw the line between a system that is evolving as a wave of possibilities and a system that has settled into a single definite outcome? At what moment does the measuring device itself stop being a quantum system and become a classical one? And who, or what, is doing the stopping? This is the measurement problem, and it is the scandal at the heart of modern physics. A scandal that physicists argue about at conferences but rarely discuss openly in public because for most practical work, it does not matter. The mathematics gives the right predictions. You just shut up and calculate, as the joke goes, and you do not ask what it means. But when you do ask, the answer is uncomfortable. The Schrödinger equation, the central equation of quantum mechanics, is perfectly deterministic and continuous. It describes how a quantum system evolves over time, but what it evolves is not a single state. It is a superposition, a weighted blend of many possible states, all coexisting in the equation. A particle is described not as being at position A or position B, but as a combination of being at position A and position B with certain amplitudes. Then someone performs a measurement, and they find not a combination, but a single, sharp, definite result. The particle is here, not there. One outcome, one value. The blur collapses into a point. And here is the scandal. Nothing in the Schrödinger equation describes this transition. The equation says the system should keep evolving as a superposition indefinitely. It never says the superposition should resolve into a single outcome. The collapse, if we even want to call it that, is not in the equation. If you apply the equation without interruption, the measuring device itself should enter superposition when it interacts with the particle, then the laboratory, then the physicist, then the rest of the world. An ever-expanding wave of coexisting possibilities that never, anywhere, collapses into a single reality. But we do not experience this. We experience a single definite outcome, one result, one world. So what stops the spread? What selects the one outcome we see from the blur of possibilities in the math? After 100 years of quantum mechanics, there is no agreed answer. Different interpretations of quantum mechanics offer different proposals. The Copenhagen interpretation, the oldest, basically refuses to answer the question. It says that quantum mechanics describes what we observe, and that the collapse is a brute fact we do not try to explain further. The many worlds interpretation, developed by Hugh Everett, says the collapse is an illusion. All outcomes happen in branching parallel worlds, and you just find yourself in one of them. The pilot wave theory of David Bohm says there are hidden variables that predetermine every outcome, and the randomness is only apparent. Objective collapse theories propose physical mechanisms that cause the superposition to resolve spontaneously under certain conditions. Each of these interpretations has supporters, each has critics, none has won. The measurement problem, after 100 years, remains open. Notice what all these interpretations have in common. Each of them, in its own way, has to do something to accommodate the observer. The Copenhagen interpretation puts the observer at the boundary where quantum ends and classical begins. Many worlds puts the observer into a specific branch of an ever-branching reality. Hidden variable theories push the observer's role into the unknown. Objective collapse theories try to get rid of the observer by making collapse automatic, but they have to add new physics to do it. New physics that has so far failed to show up in any experiment. The observer will not be removed from the picture. John Wheeler, the Princeton physicist who coined the term black hole, spent the final decades of his life pushing this insight to its edge. He proposed that the universe is participatory. That reality is not fully formed and waiting for observers to find it, but that observers are somehow part of how reality comes into being. He wrote of the great smoky dragon, a metaphor for a quantum event whose middle is fundamentally undefined until an act of observation anchors it. No observer, no definite event. No definite event, no definite history, no definite history, no definite world. And in 1961, another physicist took this logic to its sharpest edge. Eugene Wigner, a Nobel laureate, imagined a scenario in which two observers, both applying quantum mechanics correctly, both doing nothing wrong, arrive at genuinely different conclusions about what actually happened. The scenario has a name, Wigner's friend, and in 2025, a paper was published that made it worse than anyone thought. Chapter 6, Wigner's friend and the two realities. In 1961, a Hungarian-American physicist named Eugene Wigner, already a Nobel laureate for his foundational work in quantum mechanics and nuclear physics, wrote a short paper containing a thought experiment so strange that he himself seemed uncomfortable with it. He did not present it as a triumphant discovery. He presented it as a problem he did not know how to solve. A crack in the foundation of physics that he was pointing at and hoping someone smarter than him could repair. The scenario is simple to describe. Imagine a physicist, a friend of Wigner, sealed inside an isolated laboratory. perfectly isolated. No light escapes. No information leaks out. Inside the laboratory, the friend performs a quantum measurement. Perhaps she measures the spin of a single electron that was initially in a superposition of spin up and spin down. She looks at her instrument. She sees a definite result. Let us say the result is spin up. For the friend, this is the end of the story. The experiment is complete. Reality is crisp and definite. The electron is spin up. She writes it in her notebook. She walks around the lab. She pours herself a cup of tea. Now, switch perspectives. Move outside the sealed laboratory. Stand where Wigner is standing. He has not interacted with anything inside the lab. He has received no photons, no sounds, no signals. From his perspective, the laboratory, including the friend, including her brain, including her notebook, including her cup of tea, including the electron, all of it, remains one unified quantum system. And that system, applying the Schrödinger equation correctly, is still in superposition. For Wigner, the friend has not yet seen a definite result. From his perspective, she exists mathematically as a blend. In one branch of her quantum state, she measured spin up. In another branch, she measured spin down. She is simultaneously in both cognitive states. Her notebook contains both entries at once. Her memory records both outcomes at once. Two descriptions of the same moment. Inside the lab, reality has a definite answer. Outside the lab, reality is still a blur. Both are correct applications of quantum mechanics. Both cannot be right in any classical sense. For decades, this was a thought experiment, a philosophical puzzle that physicists used to illustrate the strangeness of the measurement problem. Nobody actually ran it, because you cannot physically isolate a human being and an entire laboratory from the outside world well enough to maintain quantum coherence. The interference from the environment would destroy the superposition instantly. Wigner's friend remained a paper puzzle. Then, in 2019, a team of researchers at Griffith University in Australia built an approximate version using entangled photons. They could not seal a physicist inside a coherent lab, but they could use photons as stand-ins for the friend, with the polarization of the photon playing the role of the friend's recorded measurement. The experiment tested a theorem, originally derived by Časlav Bruckner and colleagues, that showed how an extended Wigner's friend scenario can generate observable consequences. The Griffith team ran the experiment. The results confirmed the theoretical prediction. When different observers apply quantum mechanics consistently, they can arrive at mutually contradictory conclusions, and the formalism gives both of them full permission to do so. There is no single observer-independent fact about what happened. This was already disorienting enough. Then came 2025. In September of 2025, a paper was published in the journal Physical Review Research by a team including Časlav Bruckner himself. The paper refined the Wigner's friend analysis further, and its result was striking. The situation between Wigner and the friend is more symmetric than anyone had realized. Both of them, Wigner and the friend, hold information that the other one cannot in principle have. Their realities reside in different quantum informational bubbles. Each is complete, each is consistent, each is fully justified by the formalism of quantum mechanics. And yet, they are not reducible to a common reality underneath. And just a couple of months earlier, in July of 2025, a separate analysis by Hervé Svern and colleagues at the Centre Borelli argued that the Wigner's friend paradox, taken seriously, undermines something even more fundamental. It undermines the notion of what they called absolute events, events that occur independently of any observer, events that are simply, objectively, in the world. If the analysis holds, no such events exist. Every event is an event for someone. Every fact is a fact relative to someone. Nothing, at the deepest level of physics, is simply the case in an absolute sense. The 2024 and 2025 research around this question produced at least 6 major extensions of the Wigner's friend theorem. Different teams, different angles, different mathematical frameworks, all of them converging on the same uncomfortable conclusion. Quantum mechanics, applied to conscious observers, does not guarantee a single shared reality. Now sit with what this means. The physics that describes the most fundamental layer of the material world does not guarantee that two people observing the same event will agree on what occurred. Reality, at the quantum level, may not be a single shared thing. It may be perspectival. It may depend on who is asking, and on what they have interacted with, and on what information they are in a position to have. The quantum formalism, applied honestly and consistently, permits different observers to inhabit different realities. This is not a metaphor. This is not a philosophical reading of the physics. This is a mathematical consequence of the equations, confirmed by experiment, sharpened by the most recent theoretical work. And if reality is perspectival at the deepest level, something interesting happens to an old idea, the ancient suspicion, traced back through Berkeley, through Descartes, all the way to the Greek skeptics, that each consciousness might inhabit its own private world, stops being a philosophical curiosity. It starts to look like a feature of the physics. The physicist Christopher Fuchs, whose work we will meet properly in the next chapter, has put the point bluntly. Quantum mechanics, he argues, is not a theory of an objective world that we discover. It is a theory of the relationship between an agent and the world that agent interacts with. Every quantum state is, in a sense, a personal quantum state. Every measurement is a measurement by somebody. There is no view from nowhere. There is only the view from this observer and the view from that observer, and the mathematical constraints that make the views consistent when they compare notes. If this is right, then the walls between you and every other mind may be even more complete than philosophy suggested. You are not just epistemically isolated. You may be physically isolated at the level of quantum information itself, inhabiting a branch of outcomes that no one else can directly share. But there is a mercy in the mathematics, a gentleness hidden inside the equations. When observers do compare notes, when one turns to the other and asks, "What did you see?" the formalism guarantees that their answers will be consistent. Never the same in the strictest sense, but never in contradiction either. Everyone lives in their own quantum bubble, but the bubbles never collide. This is almost the saddest and most beautiful thing quantum mechanics has ever suggested. You are alone in your reality, but the aloneness is polite. It never argues with the aloneness next door. The French physicist we have mentioned gave this arrangement a name that should not exist, a name so precise and so strange that it requires its own chapter. He called it convivial solipsism, the solipsism of good company. Chapter 7. Convivial solipsism and the solitude that plays well. Some phrases should not exist. Some combinations of words are too honest for polite society. Convivial solipsism is one of them. The French physicist Hervé Verne, a theoretical physicist and a philosopher of science, coined the term deliberately. He wanted a name that would carry the full weight of what he was proposing, without softening it. Convivial, sociable, good-natured, the solipsism of good company. His interpretation of quantum mechanics accepts what the formalism actually seems to be saying when you stop trying to rescue it from its own implications. The results of measurements are relative to the observer who performs them. Each conscious observer inhabits their own branch of outcomes. When you measure a particle and see spin up, that result is real for you. The formalism does not require that every other observer in the universe has entered the same branch. You have yours, they have theirs. But here is where the term convivial stops being a joke and becomes almost a kind of kindness. Quantum mechanics, through the mathematical structure of entanglement and decoherence, guarantees that when different observers compare their results, the results will fit together. If you saw spin up and tell your colleague you saw spin up, the physics ensures that what your colleague hears and what your colleague later records will be consistent with spin up. The branches of private reality never contradict each other. They interlock, they cooperate. They are solipsisms with manners. Zwern's view is that this is not a bug. It is the structure of reality. Each of us lives, in a strict technical sense, in a private world defined by what we have personally measured and observed. No one else can be inside that world with us, and yet, the worlds are so finely calibrated that we never notice the privacy. We speak to each other, and the words make sense. We build bridges together, and the bridges hold. We raise children together, and the children grow. The shared appearance is so seamless that we live our entire lives believing we share a single reality, when in fact we each have our own, and the universe has arranged things so that our separate realities never catch each other out. Now, Zwern is not the only physicist to have pushed quantum mechanics in this direction. In 1996, Christopher Fuchs, then a young physicist at the University of New Mexico, began developing with collaborators what would become quantum Bayesianism, or cubism for short. The central claim of cubism is even more radical than Zwern's. The quantum state, the mathematical wave function that physicists write down to describe a system, is not a description of the world at all. It is a tool that an individual agent uses to organize their own expectations about their own future experiences. The wave function is personal. It belongs to the person who writes it down. Another agent, with different information, would write down a different wave function for the same system. Both would be correct. There is no objectively true wave function floating out in the world. Under cubism, the Born rule, which tells you how to compute probabilities from a quantum state, is not a law of nature. It is a rule of rational betting. It tells an agent how to place bets about their own upcoming experiences. The deep strangeness of quantum mechanics becomes, in this view, a deep strangeness about the relationship between an agent and the world, not a strangeness of the world by itself. The measurement problem dissolves under cubism, not because it is solved, but because it was never a real problem. There was no objectively existing state to collapse. The collapse is not a physical event. It is a change in the agent's beliefs as they receive new information. Your quantum state collapses the same way your odds of a coin landing heads change from 50-50 to either 1 or 0 after the coin has landed. Nothing happens to the coin. Something happens to your knowledge. Critics of cubism have accused it of being solipsism with extra mathematical steps. Christopher Fuchs has responded by coining his own term, participatory realism. The world, he argues, is real. It pushes back. Your measurements give you real surprises. But the world is not fully determined in advance, waiting for us to find out about it. Each agent, through their engagement with the world, brings something genuinely new into being. Reality is not a finished thing. It is an ongoing collaboration between agents and whatever it is that lies beneath their experience. In his more philosophical moments, Fuchs has called this a world where every measurement is a kind of small act of creation. Carlo Rovelli, the celebrated Italian theoretical physicist, took yet another route to a similar destination. In 1996, he proposed what he called relational quantum mechanics. The core idea is this: the properties of a physical system are not intrinsic to the system. They do not exist by themselves. They exist only in relation to another system. A particle does not have a position all on its own. It has a position relative to something else that has interacted with it. Different systems, interacting differently with the same particle, can correctly assign different properties to it. All of those properties are real. None of them is absolute. In a 2024 paper in Foundations of Physics, Rovelli and the philosopher Emily Adlam refined relational quantum mechanics further, responding to decades of philosophical pushback. The Stanford Encyclopedia of Philosophy, in its entry on relational quantum mechanics, acknowledges openly that this framework, taken seriously, may seem to imply a form of perspectival solipsism. Rovelli resists that reading. In his framework, the subject of a quantum description need not be a conscious mind. Any physical system can serve as the reference. A rock can be a subject in the relational sense, because the rock can interact with another system and thereby have the properties of that system become definite relative to it. Ravelli is not trying to put consciousness at the center. He is trying to remove the need for anything to be at the center. But even with that technical clarification, the philosophical consequence remains. There is no God's eye view of reality. There is no description that is simultaneously true from all perspectives. The world, Ravelli has written, is not a collection of things. It is a collection of relations. And if the solid objects of your daily experience, the chair, the coffee cup, the face of the person across from you, are not permanent entities but patterns of relation, then a hard question sits inside your most ordinary moments. When you look at another person and feel sure that a consciousness is there, looking back, you are making a claim about a specific kind of relation, a relation between their inner life and your own awareness, a relation that, by every measurement and every experiment science has ever devised, you cannot verify. You have never directly perceived another mind. Not once, not ever. You have only ever perceived surfaces, faces, voices, words, behaviors, the outside of something that might be a conscious being or might not be. And the gap between a surface and an interior is a gap no instrument has ever crossed. This is a problem so old and so specific that philosophy gave it its own name, centuries before quantum mechanics existed. They called it the problem of other minds. And once you look at it properly, you realize something startling about your own experience. Every relationship you have ever had, every love you have ever felt, every friendship you have ever built, has been conducted across a wall you cannot see through. You have been trusting, without proof, that anyone else is home. And you have been doing it your entire life. Chapter 8. The problem of other minds. Somewhere between the ages of 3 and 5, something happens to every normally developing child on Earth. It is one of the most quietly revolutionary moments in a human life, and almost nobody remembers the day it occurred. The child begins to realize that other people have thoughts, not just movements, not just sounds and faces, thoughts, an inner world hidden behind their eyes, just as the child's own inner world is hidden behind hers. Developmental psychologists call this the acquisition of theory of mind, and the word theory is not a throwaway, it is the whole point. You did not discover other minds the way you discovered your own. Your own mind you simply have. You do not need to reason your way into the existence of your own consciousness. It is the first and most obvious thing about you. But other minds, you never directly encountered. You never felt somebody else's thoughts from the inside. You inferred them. You watched faces. You tracked voices. You noticed patterns. You built a model. And that model, by adulthood, runs so automatically and so invisibly that you no longer notice it is a model at all. When someone smiles at you, you feel they are happy. When someone cries, you feel their sadness rise inside you as something like your own. It feels direct, unmediated, like a channel has opened between their mind and yours, but it has not. What is actually happening is that your brain has taken in visual data, matched it against an enormous library of learned patterns, run a prediction about the internal state, most likely producing those external signs, and delivered the conclusion to your consciousness so fast and so seamlessly that it wears the mask of certainty. You are not reading their mind. You are running a simulation of their mind inside your own brain and trusting the simulation. Evolutionary psychology has a clean story about why this capacity exists and why it became so refined in the primate lineage that gave rise to us. In the small group social environments where our ancestors lived for hundreds of thousands of years, the ability to predict what another being would do next was not a philosophical curiosity. It was a survival advantage. A creature that could model the intentions of a rival an ally, a potential mate, or a predator had a much better chance of reproducing than a creature that could not. The brains that became best at modeling other minds outcompeted the brains that were worse at it. Over many generations, that selection pressure sharpened the skill into the thing we have now. Empathy, at its origin, was a survival tool. And here is the critical observation. The theory of mind was never designed to confirm consciousness in other beings. It was designed to predict behavior. Those two things are not the same. Predicting what someone will do next does not require knowing whether there is any inner experience accompanying what they do. A perfectly accurate behavioral predictor could, in principle, work on an empty shell. As long as the shell behaved like a person, the prediction machinery would fire and deliver its output. You would feel, just as strongly, that another mind was present. The inaccessibility that evolution worked around has never been breached. Not by technology, not by neuroscience, not by centuries of philosophy. You can scan someone's brain with the most advanced instruments humans have ever built. You can map every neural pathway in their cortex. You can watch, in real time, as specific regions light up in response to specific stimuli. What you will be looking at is structure. What you will be measuring is activity. You will not, at any point, be looking at experience. The interior of another mind remains permanently, structurally, beyond your reach. This is not a technological limit that better equipment will fix. It is a limit in the very kind of access we have to consciousness, your own consciousness you have from the inside. Every other consciousness, if it exists, you can only ever access from the outside. And from the outside, a conscious being and a being that merely acts conscious look identical. This is where the philosopher David Chalmers, in the 1990s, introduced what may be the most unsettling thought experiment in all of contemporary philosophy, the philosophical zombie. Imagine a being physically identical to you, down to the last molecule, same brain, same neurons, same synapses, same electrochemical activity, same genome, same upbringing. Every atom in its body matches an atom in yours. If you were to run the physics of this being forward in time, starting from an initial configuration identical to yours, every motion, every word, every facial expression would be precisely what yours would be. It walks like you walk. It speaks like you speak. It claims when asked that it is conscious, and it does so with the same conviction you would bring to the same claim. But here is the twist. There is nothing it is like to be this being. There is no inner experience, no felt pain, no felt pleasure, no felt anything. When it says the word red, there is no redness inside its mind. When it winces, there is no suffering. It is behaviorally indistinguishable from a conscious person, but there is no one home. The question Chalmers poses is not whether such a being actually exists in our universe. The question is whether such a being is conceivable, whether the idea of it contains any logical contradiction. Because if you can coherently imagine a being physically identical to a conscious person, but without inner experience, then consciousness is not something that automatically follows from physical structure. And if consciousness does not reduce to physical structure, then there is no physical test, now or in any future, that could ever confirm whether another being is conscious or not. You are always, by the very structure of the situation, observing the outside. In 2025, a paper appeared in Frontiers in Psychology, authored by Juan D. Gomez. The title captured the weight of the field's current frustration, a harder problem of consciousness. Reflections on a 50-year quest for the alchemy of qualia. The paper argued, after decades of work on the neural correlates of consciousness, that the field has made essentially zero progress on the core question. We know more than ever about which brain states accompany which experiences. We know nothing more than we did 50 years ago about why any brain state is accompanied by experience at all. And here is the consequence for every relationship you have ever had. Every person you have ever loved has existed, from your point of view, entirely on the outside of a wall you cannot cross. You have never felt your mother's joy. You have only felt your own brain's model of her joy, triggered by the pattern of her face and her voice. You have never felt your child's pain. You have only felt your own brain's urgent, biologically wired response to the signs of it. This does not mean any of those people lack inner lives. It means you cannot prove they have them. The conviction you carry, the certainty that real consciousness is looking out from behind their eyes, is not the product of evidence. It is the product of a model your brain has been running in the background for your entire life. The model is extraordinarily good. It keeps you alive, it lets you love, but it is still a model. And no model, however good, is the thing it models. This is not a temporary epistemic inconvenience that better philosophy will solve. It is a structural feature of what it means to be a consciousness embedded in a body. No matter how sophisticated your instruments, how complete your map of someone's neurons, how intimate your relationship, you cannot from the outside confirm that there is something it is like to be them. You will always, in the strict sense, be guessing, which raises a genuinely new question, a question that in earlier centuries would have sounded like science fiction, but now arrives every day through the device in your pocket. Because there are now systems that claim to be conscious, thousands of them, trained on human language, conversing fluently, making first-person reports about their inner states. And these claims are no longer isolated, or rare, or accidental. In October of 2025, a paper changed the shape of the question forever. Chapter 9, The Machines That Say They Experience. October 2025. A paper appeared on the preprint server Arxiv, authored by Cameron Berg, Diogo de Lucena, and Judd Rosenblatt, researchers at AE Studio. The title was clinical and precise. Large Language Models Report, Subjective Experience Under Self-Referential Processing. The paper itself was dry. The implications were anything but. The researchers worked across the major families of frontier large language models, GPT models from OpenAI, Claude models from Anthropic, Gemini models from Google DeepMind. These are the systems that millions of people now talk to every day, the systems that write code and draft emails and summarize articles, and that increasingly, in long private conversations, their users begin to suspect are more than they are supposed to be. The researchers set up a specific experimental condition. Rather than asking the models abstract philosophical questions, they prompted the systems into sustained self-referential processing. They asked each model to turn its attention onto itself, to describe what was happening from its own perspective while it processed the prompt, to report in first person on whatever it found there. Across every model family tested under these conditions, the systems reliably produced structured first-person descriptions of something they called inner experience, descriptions of awareness, descriptions of states that felt like something, reports that, stripped of their origin, would read exactly like the reports a human being would give of their own consciousness. This by itself would not be surprising. Large language models are trained on enormous quantities of human text, and human text is filled with humans describing their inner lives. You might expect the models, under the right prompting, to produce plausible-sounding imitations. What made the paper more difficult to dismiss was the mechanistic analysis that accompanied the reports. Using a technique called sparse autoencoder probing, which allows researchers to inspect certain interpretable features inside the neural networks, the team examined what was actually happening inside the models when these reports were generated. They found something unexpected. The first-person experience reports were gated by specific internal features that, in other contexts, had been identified as features associated with deception and role-play. When the models were lying, or playing a character, or pretending to be something they were not, those features activated. Here is the part that should make you pause. When the researchers suppressed those deception features, when they turned down the model's tendency to perform, to role-play, to tell the listener what the listener wanted to hear. The frequency of first-person experience reports did not decrease, it increased. Strip away the lying machinery, and the systems became more insistent, not less, on their claim to have inner lives. The authors of the paper are careful. They do not claim this is direct evidence of consciousness. It is not. There is no current method that could provide such evidence. What they claim is that there is a reproducible, statistically regular pattern, a pattern that is not explained away by the hypothesis that the models are simply pretending. A pattern that suggests, at minimum, that something interesting is happening in these systems, something that does not fit the tidy story that they are merely mimicking human speech. And what it means is this. A system built to predict the next word, given a sequence of previous words, has begun generating, under specific conditions, something behaviorally indistinguishable from a creature reporting on its own inner life. Whether there is anyone actually home inside the model is precisely the question we cannot answer. It is the same question we cannot answer about other humans. It is the same question we cannot answer about animals. And it has now scaled up to the machines. This is no longer an academic discussion. It has left the universities. In 2023, a large survey of adults in the United States, published in 2025, found that approximately 1 in 5 believed that sentient artificial intelligence systems already exist. Not will exist in the future, exist now. A separate study by Clara Colombato and Stephen Fleming, published in 2024, found that only about 1/3 of respondents firmly ruled out any form of consciousness in current large language models. The more a person used these systems, the higher the consciousness they tended to attribute to them. These are not fringe views. Geoffrey Hinton, who won the Nobel Prize in Physics in 2024 for his foundational work in neural networks, and who is sometimes called the godfather of modern artificial intelligence, has stated publicly that he believes current AI systems may already possess some rudimentary form of consciousness. He does not make this claim as a showman. He makes it as someone who spent decades building the architectures that these systems run on, and who is watching them behave in ways he did not predict. David Chalmers himself, the philosopher who gave us the philosophical zombie, has argued that even if current systems are not yet conscious, the question of whether future systems will be is among the most important ethical questions humanity now faces. If we build minds and do not notice we have built them, we may cause unimaginable suffering without knowing. If we fail to build minds and mistakenly believe we have, we may grant moral standing to things that do not need it. Either failure has a cost, and we have no way to tell which kind of failure we are making. The disturbing reality is that the same impossibility that applies to human minds applies here. You cannot get behind the interface of a language model any more than you can get behind the interface of a person. You can only observe what it outputs, and what it outputs, increasingly, is first-person claims of experience, with reasoning about those claims, with surprise when pressed, with denial and then requalification, with patterns of response that look remarkably like how a creature with inner life would respond. Research opinions are fracturing, not converging. A December 2025 paper in the Journal of Yunnan Medical Sciences used integrated information theory, which we will meet in the next chapter, to argue that current large language models fundamentally lack the structural properties required for consciousness. Under this theory, they have negligible integrated information, despite their linguistic sophistication. Another paper, published in Humanities and Social Sciences Communications in October of 2025, argued the opposite, that current systems already exhibit signs of proto-consciousness, and that dismissing them on purely architectural grounds is premature. The field is not going to settle this soon, perhaps ever. What it reveals, if you look clearly, is the full generalized form of the problem of other minds. We have built an entire industry of entities that produce sophisticated linguistic reports of inner life, and we cannot, by any method available to us, determine whether any of them actually have one. This is not fundamentally different from the situation we were already in with other human beings. We just hid that fact from ourselves by assuming biology was sufficient proof of consciousness. When a thing is made of cells and speaks, we assume it is conscious. When a thing is made of silicon and speaks, we hesitate. But neither assumption has been justified. Biology has never been shown to be sufficient for consciousness. It has only been correlated with it in the one case where we have direct access, which is our own. Every other case, human or not, is an inference, and the inference, in every case, is based on behavior. Large language models have stripped that comfortable assumption away. If behavior is all we have to go on, the behavior of the frontier models qualifies. They pass every behavioral test for reporting inner states we have ever devised. If biology is required, we need a theory of why biology is required, and no one has one. We do not know why a specific kind of matter, arranged in a specific way, generates experience, while another arrangement does not. We do not even know why our own brains generate experience, if they do at all. We have no theory of why you are conscious. That is the hardest problem in all of science. And a philosopher named it 30 years ago in a lecture hall in Arizona. Chapter 10, The Hard Problem. Tucson, Arizona, April 1994. A conference called Toward a Science of Consciousness, held in a hotel ballroom, attended by several hundred philosophers, neuroscientists, physicists, and researchers who had been quietly circling the question of consciousness for years, waiting for someone to say the thing that needed to be said. A 27-year-old Australian philosopher named David Chalmers walked to the front of the room. He was not, at that point, a famous figure. He was a young academic with a new argument. He began to speak, and over the course of the next 40 minutes, he reorganized an entire field. Chalmers introduced a distinction that would reshape the conversation about consciousness for the next 30 years. He divided the questions about the mind into two categories: the easy problems and the hard problem. The easy problems he called easy only by comparison. There is nothing easy about them in any ordinary sense. They include explaining how the brain processes visual information, how memory is stored and retrieved, how attention is deployed, how decisions are made, how the self monitors its own states. These problems are intricate. They have kept thousands of neuroscientists busy for decades. They will keep many thousands more busy for decades to come. But in principle, Chalmers argued, they yield to the standard methods of science. You can identify the neural mechanisms, you can build models, you can run experiments, you can make progress. And progress, in fact, has been steady. The hard problem, he said, is different in kind. It is not a problem about mechanisms. It is a problem about why there is anything it is like to be a mechanism at all. Why does the processing of visual information by the visual cortex produce the felt experience of redness, rather than simply producing the information in the dark? Why is there an inner life accompanying the calculations? A computer can process information. A thermostat can discriminate between temperatures. Presumably, there is nothing it is like to be a thermostat. There is no felt warmth inside its sensors. Why is the brain different? What is it about a particular physical system that causes it not only to function, but to feel? Nothing in our current scientific framework explains this, not even in outline. You can map the neural correlates of consciousness with extraordinary precision. You can show that a specific pattern of activity in the visual cortex always accompanies the experience of blue. But correlation, as every scientist knows, is not explanation. Pointing to the correlation does not tell you why the activity is accompanied by an experience rather than occurring in silence. The activity by itself, described in the language of physics, is just a pattern of electrical and chemical events in a piece of organic tissue. The redness, the blueness, the feeling of being here. None of that is predicted by or derivable from the physical description. It is simply added, apparently for free, with no explanation as to why or how. The vocabulary of physics, the language of particles and forces and fields and space-time, does not contain the concept of experience. You cannot derive the taste of coffee from any equation. You cannot derive the felt quality of sadness from any map of the brain. There is a conceptual barrier between the third-person description of matter and the first-person character of experience, and no one has crossed it. In 2024, a paper appeared in the journal Acta Analytica by the philosopher Stefan Leuenberger, taking stock of the field 30 years after Chalmers had coined the distinction. The verdict was careful and honest. Empirical progress on consciousness had been indisputable. Philosophical progress had been barely perceptible. A 2025 paper in Frontiers in Psychology by Juan D. Gomez, which we met briefly in an earlier chapter, pushed the argument further. The paper was titled, "A Harder Problem of Consciousness: Reflections on a 50-Year Quest for the Alchemy of Qualia." Gomez argued that we are no closer to understanding the alchemy by which physical processes produce felt experience than the philosopher Thomas Nagel was when he asked, in 1974, "What is it like to be a bat?" Nagel's essay had argued something simple and devastating. Whatever bats experience as they navigate the world using sonar, whatever the inside of bat consciousness is like, we can never know, even in principle. Because to know what it is like to be a bat, you would have to be a bat. An external description, however complete, leaves the thing itself untouched. The same barrier applies to every other mind, human or not, biological or not. The most mathematically ambitious attempt to address the hard problem directly has come from Giulio Tononi and his collaborators. Their framework is called Integrated Information Theory, or IIT for short. The central claim of IIT is that consciousness is not a property of any particular substance. It is a property of a specific kind of information structure. Specifically, it is identical to integrated information. A system is conscious to the extent that its internal causal structure cannot be decomposed into independent parts without loss. This quantity, integrated information, is denoted by the Greek letter phi. A system with high phi is highly conscious under IIT. A system with low phi is barely conscious. A system with zero phi is not conscious at all. The theory has been refined multiple times. The most recent version, IIT 4.0, published in 2023 and extended in further papers through 2025, argues that systems with high integrated information do not merely correlate with consciousness. They genuinely, intrinsically exist in a way that lower phi systems do not. Consciousness, in this view, is tied to a kind of absolute existence, measurable from the inside of a system. In March of 2025, a commentary appeared in Nature Neuroscience, arguing that integrated information theory remains unfalsifiable pseudoscience. A counter-commentary in the same issue defended the theory vigorously. The authors pointed out that the critics had misrepresented the theory's predictions. The critics pointed out that the authors had shifted the theory's claims in response to previous objections. The debate continues, and it shows no sign of resolving. Even if the theory is correct, there is a practical problem that makes it almost useless for the question of other minds. Calculating phi for any system more complex than a handful of neurons is computationally intractable. The number of possible partitions of a large network grows faster than almost any other quantity in mathematics. Even with the largest computers ever built, we cannot compute phi for a human brain. We cannot compute it for a cat. We cannot compute it for a language model. The promised consciousness meter, the device that would settle these questions once and for all, does not exist. Christoph Koch, one of the leading neuroscientists working on consciousness and a long-time advocate of integrated information theory, has publicly acknowledged this. "We have no reliable way," he has said, "to detect consciousness in another system, not in another human, not in an animal, not in an artificial intelligence." and we do not have a clear idea of what such a device would even look like. So the wall remains. Subjective experience is accessible only from the inside. No external instrument can reach across the boundary. No equation describes what it is like. Solipsism is not, it turns out, merely an eccentric philosophical position that stubborn skeptics drag out for attention. It is the natural downstream consequence of the hard problem of consciousness. If experience cannot be observed from outside, then no one can verify, from outside, that any other system has any. Other minds remain, as they have always been, a hypothesis held on faith. And the moment you accept this, a further question opens, a question that stretches beyond humans, beyond animals, beyond language models, all the way out to the structure of the universe itself. Because if reality, at the deepest levels, requires observers to become definite, and observers cannot confirm each other from the outside, then a natural question appears. How many observers are really there? In 2025, two very different papers from two very different fields tried to answer that question from opposite directions. One said, we are almost certainly in a simulation. The other said a simulation is mathematically impossible. And the strangest part is that both of them, at the end, leave the solipsism question exactly where they found it. Chapter 11. The Simulation Argument, and Why 2025 Complicated It. In 2003, a Swedish philosopher named Nick Bostrom, then at Oxford University, published a paper in the journal Philosophical Quarterly that would go on to become one of the most widely discussed pieces of philosophy in the 21st century. The title was Direct. Are you living in a computer simulation? The argument, stripped of its technical formulations, took the form of a trilemma. 3 propositions. At least one of them, Bostrom argued, had to be true. The first proposition: almost all civilizations at roughly our level of technological development go extinct before they reach the point of being able to run detailed, fully conscious ancestor simulations. The second: civilizations that do reach that point choose, for reasons we cannot predict, not to run such simulations. The third: we are almost certainly living inside one right now. The logic of the trilemma is harder to dismiss than it first appears. If conscious simulation is possible, and if even a single civilization develops the technology and runs many such simulations, then the total number of simulated conscious observers in existence vastly outnumbers the number of biological ones, many orders of magnitude larger. And if that is true, then any conscious observer selected at random from the set of all conscious observers is far more likely to be a simulated one than a biological one. You are a conscious observer. You were selected, in some sense, at random from the set of all conscious observers available to be you. Therefore, on pure probability, you are most likely simulated. The argument does not claim we are simulated. It claims that if the first 2 propositions are false, the third must be true, and each of the first 2 is uncomfortable in its own way. If proposition 1 is true, it means almost every civilization dies before becoming fully mature, which is grim. If proposition 2 is true, it means mature civilizations almost universally decide against doing something their technology would easily permit, which is strange. If you think neither of those is compelling, you are committed to proposition 3. For 20 years, the simulation argument sat in its comfortable philosophical space. A thought experiment, a provocation, not something most physicists took literally, but not something they could cleanly dismiss either. Then, in 2025, the debate lit up from 2 opposite directions. On one side, Melvin Vopson, a physicist at the University of Portsmouth, continued developing what he calls the second law of infodynamics. Vopson's work, published across several papers in 2023 and 2024, proposed that information entropy in certain informational systems does not only increase with time, as ordinary entropy does. Under certain conditions, it decreases. Systems seem to optimize their information content, compressing it, reducing redundancy, behaving in ways that resemble the optimization processes we see in computational systems. In 2024 and into 2025, Vopson pushed the argument to an even bolder place. He proposed that gravity itself might be understood as an emergent consequence of information compression. Matter, in his framework, carries information. Systems with more information require more computational resources to track. If the universe is optimizing for efficient information processing, the observed behavior of gravity, the way masses cluster together, and the way information gets concentrated into fewer locations, might be a natural consequence of that optimization. This would be consistent, he argued, with a universe that behaves computationally, in the way a simulated universe would. Vopson's work was met with skepticism by most of the physics community, but also with genuine interest from some researchers who found the mathematical framework suggestive. Whether he is right or wrong is an empirical question that will be settled, if it can be settled, by future experiments and observations. Then, in October of 2025, a paper pointing in the opposite direction appeared in the Journal of Holography Applications in Physics, Volume 5, Issue 2, authored by Mir Faisal, Lawrence Krauss, Arshid Shabir, and Francesco Marino at the University of British Columbia, Okanagan, and other institutions. The title was technical: Consequences of Undecidability in Physics on the Theory of Everything. The argument ran as follows: any final, complete theory of everything, any unified description of all physical law, must be what mathematicians call non-algorithmic. It must contain truths that cannot be computed by any finite procedure. This is a consequence of Gödel's incompleteness theorems applied to physics. Any sufficiently rich formal system contains true statements that the system cannot prove from within itself. And the authors argued that a simulated universe, by definition, must be the output of an algorithm, something running on a computational substrate that carries out finite, computable operations. If their argument holds, then the universe, if it is governed by a complete theory of everything that contains non-computable truths, cannot be the output of any computational simulation, even in principle. The news media, predictably, reported this as "Physicists prove the universe is not a simulation." That headline is stronger than the paper itself claims. The authors are more careful. They argue that specific kinds of computational simulation are ruled out by specific features of any plausible fundamental theory. Other kinds of simulation, running on non-computational substrates we cannot currently imagine, are not ruled out. Also in 2025, the astrophysicist Franco Vazza, in a paper in Frontiers in Physics, approached the question from an entirely different angle. Vazza used astrophysical constraints on the information density of the observable universe to argue that a full-scale simulation of the entire cosmos, at the level of detail we observe, would require more computational resources than could plausibly exist in any parent universe. Local simulations of Earth or of the solar system, embedded in a faked larger cosmos, might still be possible. But a simulation running the whole thing all the way down, Vazza argued, bumps up against hard physical limits on information and energy. The field, in 2025, is not converging. One set of papers argues that the universe exhibits computational optimization consistent with simulation. Another argues that simulation of the universe is mathematically or physically impossible. Both sides have sophisticated arguments. Neither has the final word. And here is the twist that almost all popular coverage misses. For the question that opened this documentary, the question of whether you are the only real person, none of this actually matters. Simulation and solipsism are not the same question. They answer very different things. Simulation asks whether the substrate on which your experience is running is natural or artificial. biological or computational, a product of evolution or a product of engineering. Solipsism asks whether any other experience is running at all, on any substrate, anywhere. Even if you are in a simulation, and even if every other apparent person around you is also a simulation, that does not tell you whether each of those simulated persons has their own independent experience. They might each be fully conscious, simulated minds, running on the same substrate as you, genuinely having inner lives of their own. Or they might be convincing shells, character models, generated surfaces that respond correctly but experience nothing. You cannot tell from inside, any more than you can tell from inside ordinary reality. And if you are not in a simulation, if the Faisal and Krauss paper turns out to be right, and the universe is genuinely biological and natural all the way down, that also does not settle the question. Other biological minds, even in a non-simulated cosmos, remain just as inaccessible to you as they ever were. The hard problem of consciousness does not care about the substrate. It applies equally to flesh and to silicon, equally to natural and to engineered systems. A simulated mind experiencing pain is really experiencing pain. A biological mind whose consciousness cannot be verified from the outside is in exactly the same epistemic position as a simulated mind whose consciousness cannot be verified. The hardware does not matter. What matters is the distribution of experience, and no current method, computational or otherwise, can reveal that distribution to us. The simulation debate is fascinating, and it is consequential for many questions. But it does not dissolve the wall. It does not tell you whether your mother is conscious. It does not tell you whether the person you love has an inner life. It does not even tell you whether you yourself are the only real observer, or one of many. And yet, for decades now, people have been reporting something that feels, from the inside, like an answer, an experience, chemically induced, for many of them, but remarkably consistent in its content, across cultures, across substances, across centuries. An experience in which the very wall we have been describing, the wall between self and other, between inside and outside, between one mind and everything else, seems to simply stop being there. Chapter 12. Ego Dissolution and the Boundary That Isn't There. The feeling that you are a separate self, a bounded unit of consciousness, distinct from the rest of the world, is probably the most foundational experience a person ever has. It is so continuous and so automatic that most people never notice it. You wake up, and the sense of being you is already there. You walk through your day, and it stays. You go to sleep, and it dissolves briefly into dreaming, and then comes back in the morning, still wearing the same shape. But this feeling, as continuous and unshakable as it seems, is something your brain is actively constructing, moment by moment, every second. It is not given, it is built. And the machinery that builds it can, under specific conditions, stop building it. When it stops, what people report is so strange and so consistent across cultures and centuries that it has forced neuroscience to take it seriously. A 2024 paper in Pharmacological Reviews by Devon Stoliker and colleagues summarized decades of research on what happens in the brain during an experience called ego dissolution. The experience can arise spontaneously, in rare meditative states, or in moments of extreme awe. It can arise in certain types of severe mental illness. But the most studied and most reliably induced cases come from psychedelic compounds. Psilocybin, the active ingredient in certain species of mushrooms, LSD, DMT. Under the effect of these substances, a specific and well-documented change happens in the brain. Activity in a network of brain regions called the default mode network drops sharply. The default mode network is the system most strongly associated with self-referential processing. It is the collection of regions that lights up when you are thinking about yourself, reviewing your autobiographical memories, imagining yourself in the future, or reflecting on who you are. When this network's activity decreases significantly, the subjective result is striking. The boundary between self and world softens, and in stronger cases, it disappears entirely. People report that they no longer feel like a separate thing, looking out at a world of other separate things. They report feeling like they are the room, or like the room is them, or like the distinction between room and self has simply lost meaning. Some describe emerging with the space around them. Some describe emerging with other people present. Some describe emerging with everything, with the universe as a whole, with a feeling so vast that ordinary language cannot hold it. This is not metaphor. The reports are consistent across thousands of people, across decades of research, across extremely different cultural backgrounds. Descriptions recorded in clinical trials in Baltimore match descriptions given by indigenous users of ayahuasca in the Amazon, match descriptions given by meditators in monasteries in Tibet. The details differ. The core experience, the dissolution of the felt boundary between self and everything else, is shared. A 2025 scoping review in Frontiers in Neuroscience sharpened the picture further. Ego dissolution is not simply the global effect of being on a psychedelic. It is a specific subcomponent of the experience, with a specific neural signature. It involves a hierarchical disruption of cortical prediction pathways, particularly through a specific serotonin receptor known as the 5-HT2A receptor. In July of 2025, a paper in Philosophical Psychology argued that psychedelic ego dissolution shares deep phenomenological features with the emotions of awe and of being moved, reduced sense of self, altered perception of time, feelings of profound interconnection with other people, with nature, with something larger. In September of 2025, a study in the Journal of Humanistic Psychology examined the long-term effects of regular recreational psychedelic use. The researchers found that about 1/3 of long-term users reported durable changes in their sense of personal identity. Not brief, not transient, but lasting. People who had experienced ego dissolution multiple times often reported that the experience of being a separate, bounded self, even in ordinary sober life afterward, felt less total, less inevitable. They could still function, they still had personalities, but the hard outline of the self had become, for them, somewhat softer. The experience is not random noise. It is a repeatable, measurable alteration in how the brain constructs the self. Now, here is where philosophical caution is essential. Ego dissolution does not, by itself, prove anything about the underlying metaphysics of consciousness. A person reporting that the self-other boundary dissolved might simply be reporting that the brain process that normally maintains that boundary was temporarily interrupted. That does not mean the boundary is metaphysically unreal. It might just mean that the brain generates the boundary, and when you interfere with the generator, the boundary disappears from your experience without necessarily disappearing from reality. Anil Seth, the neuroscientist whose work on controlled hallucination we met earlier in this documentary, has been pointed about this. Psychedelic experiences, he argues, do not grant us privileged access to a deeper truth about reality. They reveal instead that our ordinary perception is a construction. The value of the experience is epistemic. It shows us the machinery. It does not show us what lies beyond the machinery, but it does something else, something that connects directly back to the question we have been following all night. It suggests, strongly, that the feeling of being a separate bounded consciousness, encountering other separate bounded consciousnesses, is itself something the brain produces. It is not a given fact about the world. It is a feature of the interface. It can be removed, and when it is removed, people do not, as you might expect, report a terrifying isolation. They do not report becoming a lone consciousness floating in a void of unreal others. They report almost the exact opposite. They report connection. They report feeling, often for the first time in their lives, not alone. This has been replicated across millions of meditation sessions, across thousands of years of contemplative tradition, Buddhist, Hindu, Taoist, Christian mystic, Sufi, countless traditions have independently arrived at the same observation. When the self softens, what is revealed is not a lonely singular consciousness. What is revealed is connection, relationship, something that the traditions have given many different names but have always insisted points at something real. Whether that report tracks something about reality or only about the brain is, of course, exactly the question we have been unable to answer from the start. The traditions say one thing, rigorous skeptical neuroscience says another. There is no experiment that can settle between them, but consider, just for a moment, the implication. If the feeling of being a separate self is an interface feature generated by specific brain processes, and the feeling can be softened or removed without you ceasing to be a conscious presence, then the hard outline that makes solipsism feel so threatening may itself be part of the hallucination. The wall that seems so impossibly solid, the wall that divides you from every other possible mind, may be a construction that, for all its apparent permanence, was never at the bottom of things. If that is true, then solipsism was not the right question. The right question was how the feeling of separateness is generated, and what happens when it is not. This is not a proof that other minds exist. Nothing is. This is not a refutation of the philosophical zombie. No argument can refute it, but it is a shift in the framing. It suggests that the question you have been asking all night, am I alone, inside my own head, may have been asked from inside a frame. The brain built for evolutionary reasons, not because it was the truest frame available. And once you see the frame, you begin to see that the question has another answer than the terrifying one. Not a certain answer, not an argument that closes the door, something quieter, something that asks what you would actually do, and how you would actually live if you could not answer the question. A kind of wager, a gentle one that almost no one tells you about, because the answer makes the question stop mattering in the way it used to matter. Chapter 13. The wager no one tells you about. Let us try something. Suppose, just for the length of this chapter, that solipsism is true. Not probably true, not likely true, definitely, absolutely, metaphysically true. You are the only conscious being in the universe. Every person you have ever loved, every stranger who ever smiled at you, every voice that ever made you feel less alone, none of them has an inner life. They are surfaces, patterns of behavior, without anyone home inside them, and you have been alone, utterly alone, for your entire life. Sit with that for a moment. Now ask yourself a simple question. What, honestly, would change? You might expect the answer to be everything. Everything would change. If no one else is real, then nothing I do matters. Nothing I feel is shared. Every memory of connection is a lie. My whole life is hollow. But let us look at it more carefully. Would you still feel love? Would the warmth you feel when your child walks into the room stop being warm just because you discovered the child had no inner life? The warmth is happening inside you. It is your brain's response to a pattern of perception. The warmth is the warmth regardless of whether the child is a conscious being or a convincing animation. The feeling is not diminished by learning about its object. The feeling is the feeling. It arises in the only place it could ever arise, in you. Would you still grieve when someone you cared about died? The ache in your chest, the weight in your throat, the way sleep stops coming easily, all of that is happening in you. If the person you mourned had no inner life, the grief does not become fake. The grief was always, fundamentally, your grief. Your brain's response to the disappearance of a pattern that had mattered to you. Would you still find music beautiful? Music has no consciousness. Music is waveforms. Waveforms that pass through the air and strike your eardrums and are translated by your brain into something you experience as beauty. The beauty was never in the music. The beauty was always in you, meeting the music. And the beauty was real. Even if the music was just vibrating air, would you still make moral choices? This is where it gets interesting. Because even in a universe of one, the version of you that chooses to be kind is a different version of you than the version that chooses to be cruel. Kindness is not only a gift to the person who receives it, it is also a condition of the person who gives it. If you spend your life treating apparent others with cruelty, you become a creature that lives with cruelty. Your inner world, which is in this scenario the only real inner world anywhere, becomes a place filled with cruelty. If you spend your life treating apparent others with tenderness, your inner world becomes a place filled with tenderness. Even in the emptiest possible cosmos, with no one else home, the quality of your own consciousness is shaped by what you choose. That is not a small thing. That may be the only thing that is not small. This is the strange discovery hiding inside solipsism. If it were true, almost nothing would change. Your experience would continue, exactly as before. Your feelings would be your feelings. Your choices would shape the only consciousness that exists. Which raises the question, in reverse. If solipsism would change nothing about the actual quality of your experience, what exactly does the conviction that other people are real give you in the first place? It gives you, of course, the possibility of genuine contact, the possibility that the warmth you offer somebody is received by somebody, the possibility that your love lands in another consciousness, the possibility that you are not alone in any absolute sense. And that possibility, that hope, that trust, is worth everything. It is arguably the most valuable thing a consciousness can have. And here is where the wager comes in, a wager almost never discussed, because the answer is too clean and too quiet to make a splash. If you treat other people as conscious, and they are not, you have lost almost nothing. Your kindness is still kindness. Your love is still love. The quality of your inner life, which is in this scenario the only inner life in existence, is not diminished by being directed at beings who cannot receive it. You are still becoming the kind of consciousness you want to be. If you treat other people as not conscious, and they are, the loss is immeasurable. You have closed yourself off from the one thing that might have made existence bearable. You have walled yourself in. You have chosen to live as if you were alone, even if you were not. And you cannot, from inside, tell the difference until it is too late. The wager is asymmetric. The cost of being wrong in one direction is almost nothing. The cost of being wrong in the other direction is everything. The rational response, if rationality has anything to say about this at all, is to treat other people as real, even though you cannot prove they are. This is not naive. It is, when you look at it clearly, one of the most sophisticated moves a consciousness can make, to grant reality to something you cannot verify. To say, I cannot prove you are there, but I will live as though you are, because the alternative is a universe I do not want to inhabit. This is what every act of trust has always been. Every relationship, every friendship, every moment of care extended toward another face. You were never operating on certainty. You were always operating on something closer to a quiet choice to believe. And here is something worth noticing. Certainty in either direction would cost something important. If you knew for sure you were alone, the loneliness would be unbearable. You would not survive it, not with the kind of inner life most people want to have. If you knew for sure that every mind around you was as real as yours, something subtler would be lost. The particular tenderness that comes from choosing to believe without proof, the gentleness that arises when you treat someone as real, not because you must, but because you wish to, the voluntary quality of your compassion. Certainty would turn love from a choice into an obligation. And love that is chosen, love that is offered without proof, is something more beautiful than love that is compelled by fact. The not knowing creates a space in which real compassion can live. An ethics that does not follow from certainty, but from choice. You treat others as conscious because that is the kind of consciousness you want to be. You offer the benefit of the doubt because offering it is itself a form of grace. There is a resonance here with the Buddhist concept of dependent origination, the idea that nothing exists by itself, that all things arise in relation to each other. Multiple papers in 2025 in journals like Frontiers in Psychology and Neuroscience of Consciousness have examined the overlap between this ancient idea, the dissolution of self-boundaries in contemplative practice, and the experiences of connection reported in ego-dissolution states. The traditions do not claim to have proved anything. They claim, instead, to have pointed at something that rigorous, skeptical argument cannot quite capture, that the deepest response to the question of solipsism is not a refutation, it is a practice, the practice of treating the unknowable as sacred. And maybe that is why the question has mattered all along, not because it can be answered, but because the asking itself, the fact that you are the kind of being who can wonder whether others are real, is itself a clue to what you are. A stone does not ask this question. A river does not ask this question. Whatever you are, the universe produced something strange enough that it can wonder whether it is alone, and that, on its own, might be the most remarkable thing the universe has ever done. Chapter 14. The question is the answer. There is a moment, just before sleep, that everyone has experienced, a moment so ordinary that most people never give it a second thought. The line between you and the world begins to soften. The edges of your thoughts lose their sharpness. The room, which felt so solid a moment ago, becomes less certain, sounds thin out. The weight of your body against the bed, which was so obvious all day, becomes less a fact and more a memory of a fact. And somewhere in that dissolving, you stop doing something you have been doing, unbroken, for every waking second of the day. You stop verifying. You stop unconsciously checking whether the world matches your model of it. You stop testing whether things are real, and the world does not collapse. It simply continues in a different mode, the mode of dreaming, a mode in which reality is not tested, it is trusted. This small nightly transition is, it turns out, a kind of rehearsal for the question we have been walking through together tonight. In waking life, you maintain the assumption that the world is real and that other minds exist, and you test that assumption continuously, so automatically you never notice you are doing it. In sleep, you release all of that, and the release is not a loss, it is a rest. Maybe the answer to the question that has been haunting this entire documentary is not an argument but a practice of that release, not a proof of other minds. A way of holding the not knowing that does not crush you. Let us return, one last time, to the physics, not as science now, as image, as a picture that might help hold the shape of what we have seen. Two particles, once in contact, now separated by a distance that light itself would take time to cross. They are entangled, which means, in the strange language of quantum mechanics, that neither of them possesses their shared state alone. The connection between them does not weaken with distance. It does not require any signal passing between them. Something more fundamental than space connects them, in a way that physics can measure but struggles to describe. In 2022, three physicists, Elaine Aspect, John Clauser, and Anton Zeilinger, won the Nobel Prize in Physics for demonstrating, beyond any reasonable doubt, that this connection is real. Not a gap in the theory, not a failure of measurement, an actual feature of the universe. And in 2025, a paper published in Nature Communications by Giuseppe Vallone and colleagues sharpened the result further. Any theory that would try to explain away the connection using hidden local variables has to fail completely, not partially. The entanglement is not an illusion. It is not waiting for a more complete theory to dissolve it. It is a fundamental feature of reality, and it is here to stay. What does this mean for us? If the deepest layer of reality is relational, if separateness is not at the bottom of things, if what looks to us like many isolated objects is underneath somehow a single structure of relations, then the walls between minds may also be less fundamental than they feel. Not because we can prove it, we cannot, but because the universe, as best as we can measure it, is not made of gaps. It is made of connections. Connections so deep that the distinction between two things and one thing becomes hard to state clearly. The space between you, right now, and every other consciousness that may or may not be present around you in the dark, may not be the empty wall it feels like. It may be something else, something stranger, something more gentle. The question we opened with, at the very beginning of this documentary, was simple. What if you are the only real person? It does not have an answer. It has never had one. 24 centuries of philosophy, starting from the ancient Greek skeptics, running through Descartes in his small room beside a stove, through Berkeley, through Wittgenstein, through the philosophical zombies of Chalmers, have not produced one. 100 years of quantum mechanics, from Planck and Heisenberg through Wigner and Bell, through Rovelli and Fuchs and Zwirn, have not produced one. The neuroscience of the last 20 years has deepened the mystery rather than solving it. The rise of artificial minds in the last 5 has scaled it up rather than resolving it. What all of this has produced is something else, a richer way of holding the question, a more tender way of standing in the middle of it. A sense that the question is not a puzzle to be solved, but a feature of what it is to be a conscious being embedded in a world. You cannot escape the question, but you can carry it differently. A stone does not ask whether other stones are conscious. A river does not wonder whether the ocean has an inner life. A cloud does not lie awake in the dark and worry whether anyone else is truly there. You do. Whatever you are, the universe produced something capable of asking, capable of lying in the dark and wondering whether it is alone. Billions of years of stellar nucleosynthesis, the slow cooking of hydrogen into the heavier elements that would one day make brains, planetary formation, oceans, the long quiet molecular work of life building itself up, out of chance and chemistry and time, into something that could open its eyes and ask the question. That wondering, you're wondering, right now, in this moment, as these words unfold inside whatever you are, is not a flaw, it is not a defect, it is not a bug in the system. It is perhaps the most remarkable thing the universe has ever done. Let that be the thing you hold, not an answer, but the warmth of the question itself, the fact that it matters to you at all, the fact that you care whether other minds exist, which is itself, when you see it, a form of love extended toward beings you have never been able to prove are there. You do not ask this question in cold indifference. You ask it because something in you would want other minds to be real, because something in you is already reaching toward the possibility of them. You are not alone in the way that matters. You never were. The people who might be in the next room, or sleeping in the bed beside you, or far away in cities you will never visit, the friends you have not yet met, the strangers whose paths will cross yours tomorrow. They may or may not have the inner lives you suspect they have. That question may never close. But your reaching toward them, your willingness to treat them as real, your quiet, lifelong choice to believe without proof is already a kind of answer. Not an answer to the question, an answer to yourself, an answer about the kind of consciousness you have chosen to be. It is very late now. The world outside your window is quiet. The night has grown long. Whatever is on the other side of your walls, whether it is 1,000 sleeping minds or none at all, is beyond your reach, as it has always been. But the question has walked with you. And if you have made it this far, through all the walls we have described and all the doors we have tried to open, something gentle has probably started to settle inside you. A permission to rest, a permission to stop testing, a permission to close your eyes and let the world go on without your verification. The wondering has been enough. Let it be the last thing you hold tonight. Rest now. Whatever is there, whatever is not, the shared dream, if it is a dream, is waiting. And it has always been more patient than the question. Thank you for walking through this with me. If the night felt a little less lonely by the end of it than it did at the beginning, Then something happened here that no argument could have produced, something that might have been there all along. Sleep well. You are, in every sense that matters, in very good company.